Okay, guys. So yeah, good evening to everyone. Uh, I think yesterday I talked about a little bit of Python also, along with our theoretical along with our theoretical aspect. We discuss about a normal distribution. I think all kind of a probability distributions we discussed in yesterday's session, and then after that I think we discuss about a Python, that how we can utilize the concept or the idea of Python in a machine learning, sorry, in a no, with the statistics. Okay, so and that is why I think I show you that, yeah, how you can what are the some basics concepts in Python. Even there are more. So like if you guys are prefer to or willing to learn by yourself, a very in a very little amount, so even you can try to uh, go through. I shared one PDF with you already. I will share some more PDF with you guys, and you can try to go through those PDF, and you can try to learn. Okay, like by yourself. Even you can ask me in a in a session, not in a session actually, but yeah, in a personal through LinkedIn or through mail. That is completely fine. Even we are planning to do some more to extend this session, to do session on Python, then a session on machine learning. So yeah, we will inform you if you are interested, if you continue your journey along with me or along with MSME, so you can join those programs. Okay, now today I think we are going to, as I told you, that one thing which left out, which I maybe forgot to explain you, that is interquartile range. Okay, so even interquartile range is used for the same purpose. Okay, so I think we have an idea of already we discussed about the empirical rule, 68, 95, 98 rule. Sorry, 68, 95, 99 rules. So with the help of that rule, we are able to decide whether in my data set we are having an outlier or not. So in a similar way, with the interquartile range also, we are able to decide whether in my data set we are having an outlier or not, or even we call them extreme outlier. Okay, so first try to you are able to understand the interquartile range only with the help of the percentiles. Okay, so percentile is again one of the kind of a descriptive statistics. Okay, percentiles. Okay, so percentile means what, guys? So percentile is again it is also a measure of central tendency that divide a group of a data into 100 parts. Okay, so it is again a measure of central tendency only, because as I told you, it is also a part of a descriptive statistics itself. So it is a measure of central tendency which can divide your data into or sorry, which can divide a group of data into 100 parts. Okay, so I think if any one of you participate in a GMAT examination, GRE, or a CAT, so there people are the people are giving you the percentiles. Okay, so you got your percentile. So percentile means, so suppose someone of you got maybe a 90 percentile. Okay, so someone of you got 90th percentile. It means that out of total population, okay, so total population means out of total students who participate in an examination, you are you are better than, or you are better than 90% of the people. Okay, so this is what a meaning of a 90th percentile over there. Okay, so percentiles is yeah, it's a measure of central, and it divides the data into you can say into 100 parts. Okay, and then there are different ways through which you can calculate a percentile. So even there is a formula to calculate a percentile. So you can calculate the location of percentile by using this formula. Okay, so a p upon 100 into n. Now what is this I? So I is nothing but it's a percentile location which we need to find out. Okay, so I is nothing but it's a percentile location which we need to find out. Then this I is nothing but like percentile of interest. So in a question, suppose someone asks you find the 30th percentile of this data set. So 30 will be your P. Okay, so P is nothing but the percentile of interest. And then at last, and I think you all know about the n. So n is nothing but number of value in your data set. Okay, so number of like a value in your data set. Okay, now there is like one more thing which you need to like remember, that after finding out this I, maybe it may possible that you will got a whole number. So it may possible that I will be the whole number, or it may possible I will not be the whole number. So if I is a whole number, okay, so suppose if you try to find out the percentile of in your data set and you got the whole number as a result, so at that point of a time, so at that point of a time, so so the percentile, so the I, so now after calculating this I, so suppose it is like it is a whole number, then what you need to find out, so you need to find out the value at ith location. So you need to find out the average of the value at the ith location plus plus I plus 1th location, okay, and then divide by 2. Okay, so you need to find out the average of like this shoe value if it is a whole number. Okay, so even you can write down that if I is a whole number. And second condition, if I is not a whole number, so if I is not a whole number, then the percentile, the pth percentile value is nothing but I plus 1. Okay, so this is how you can find out the percentile. Okay, I will don't worry guys, I will take one example and make you understand this like a formula, or yeah, you can if you want, you can take a screenshot or just write down this like thing. Okay, I will give you a 1 minute of time. You can, if you want, you can write down this like formula in your notebook. And even here also, the first step is you need to sort the values. We need to sort the data set. This is going to be the first step, and then only you are going to find out the I. And if I is a whole number, then this is going to be a percentile, and if I is not whole number, then this is going to be a percentile. Okay, clear? Okay, now let me take a dummy data set for you, and then I will ask you then find the percentile value. Okay, and you can try to like find it along with me. Okay, so suppose I'm having like this number with me. So suppose this is my like data set. So I'm having like 14, 12, then a 19, 23, 5, 13, 28, and 17. Okay, so guys, just try to find out the 30th percentile of this data set. Okay, 30th percentile of this like data set. Okay, so guys, just quick, I'm also with my calculator and do along with me. So I think P is equals to nothing but 30 and N is nothing but like 8. So first we need to organize my data set in a ascending order. So my D dash will be what? So my D dash will be like 5, then 12, then 13, then I think 14, then a 17, 19, 23, and 28. Now what is I? I think so I is very like easy from here. So 30 upon 100 into 8. So this will be nothing but 24 divided by 10 is nothing but 2.4. Okay, so now this is not a whole number, guys. Yeah, this is not a whole number. So your percentile will nothing but the value on at the location I plus 1. Okay, so what you need to do, you need to find I plus 1. So my I plus 1 is nothing but it will be a 3.4. So after rounding off, you will get 3. Now just try to get what is the value at like third position. So the value at third position is nothing but 30. Okay, so 13 is the 30th percentile. So my answer will be 13 is the 30th percentile of this data set. Okay, so this is my answer. Fine, guys. Anyone having any doubt regarding a percentile? Okay, and even guys, I think yesterday itself we talk about a NumPy. Okay, even we not go into the detail, but I shared one PDF of NumPy with you. So even you can try to find out this percentile with the help of NumPy. So just like you are writing like mean, median, mode, and all. So even you can try to write like np dot percentile, and then you can pass your data set, and then you can by after comma you can try to write which percentile value you want to find. Okay, so even you can try to check it out right now. So suppose I need to run this import numpy snp. Now take like this same data set, no issue. So what are the values inside that data set, guys? So anyone can tell me the value? Okay, if not, I will see by myself. So it will be 14, then I'm having a 12, then I'm having a 19, then I'm having a 23, then I'm having a 5. Okay, let me check again. Then I'm having a 13, then a 28, and then 17. So I think 1, 2, 3, 4, 5, 6, 7, 8. 8 values are there. Now, if I want to find out the percentiles, np dot, I can write np dot percentile. I can pass my data set, and then I can give my percentile value. So I want 30th percentile. Now check. Yeah. So 13.1. Okay, I think we are getting the same answer from here also. We are getting the same answer over here also, 30. So this is how you can find out the percentile with the NumPy also. So without doing any calculation, just a single line of a code, with just single line of code, you can try to calculate the percentile value. Okay, now guys, just come on to the main idea, come on to the main point, which through which we okay, so percentile, even whatever the things which we have learned till now. Okay, so what, even if it is a central tendency, even it is a measure of dispersion, we always try to learn the significance. Okay, so here also I need to tell you the significance. Okay, that is the main part, that is the main thing. Okay, so the significance comes with this quartile. Okay, now guys, if you want, you can try to write a definition for quartile. Okay, so quartile is what? Quartile is, again, it is a measure of central tendency that divide a group of data into 4 subgroups of 4 parts. Okay, so just like percentile, so percentile divides the data into into 100 parts. Here quartile divide a group of data into 4 parts. Okay, fine. So like what are those 4 parts? So it is nothing but like Q1, then a Q2, Q3, and a Q4. So Q1 is nothing but it's a 25th percentile of your data set. 25th percentile of your data set. Then Q2 is nothing but a 50th percentile of your data set. Then Q3 is nothing but a 75th percentile of your data set. And Q4 is nothing but a 100th percentile of your data set. Okay, so in this way it divides your data, or it divides a group of data into 4 parts. Okay, or you can say a 4 equal parts. Okay, guys, and even this Q2, this 50th percentile, this Q2 is nothing but what? This 50th percentile is nothing but a median of your data set. Okay, so this is nothing but a median of your data set, capital M. Okay, clear? Now the significance of this is is by denoted. So just like in case of like a standard deviation, we are trying to like learn something empirical formula. So here we are having something which is called an interquartile range. Okay, so interquartile range, which is written as IQR. Okay, so IQR is nothing but it is equals to sorry, Q3. Okay. So it's nothing but a Q3 minus Q1. Okay. So this is a meaning of IQR. And now guys, just try to understand. So if my value, okay, so now if my value is so in your data set, so suppose you are having a like maybe any kind of a data set. So you may have a like any kind of a data set. So if you're like a data set, in your data set, if your value is maybe below, okay, so just like in empirical formula we are having a like mu plus minus 3 standard deviation, that is the last thing. So if you got any value like below this mu minus 3 standard deviation, or if you got any value beyond this mu plus 3 standard deviation, so both the values are considered to be an outlier. Okay, remember this thing. Okay, we already learned about this particular topic. Okay, if we got any value in my data set like below mu minus 3 standard deviation, or if I got any value like above 3 mu plus 3 standard deviation, then both the values are considered to be an outlier. Yes. So similarly guys, similarly over here, if I got like any value, if I got any value below like this Q1 minus, okay, 1.5 into IQR. Okay, so 1.5 into IQR, or if I have any value above Q3 plus 1.5 into IQR, then both the values, so if I got any value, okay, so if I got any value beyond like below this, or if I got any value above this, so those values are considered to be an extreme outlier. Okay, those values are considered to be an extreme outlier. Okay, so this is also so I think guys, now we have two ways to identify an outlier in my data set. Okay, so even we can try to identify an outlier with the help of empirical formula, and here we can also identify an outlier, and but this time these are called an extreme outlier, not only the outlier. So this time it is called an extreme outlier. Okay, and this time we are able to identify an outlier with the help of IQR, interquartile range. Okay, fine guys, anyone having any doubt regarding this interquartile range, regarding this concept of interquartile range? Okay, even you can try to check. Okay, just create a dummy data set, and don't worry, I'm going to take a like one example with a Python, so don't worry about that. But even if you want, you can take a like one dummy data set. You can intensely put a like maybe 2 or 3 outliers over there, big outlier, not a small outlier. Just try to put a like 2 or 3 big outlier over there, and then try to calculate this thing. You are able to get like yeah, with this formula you are able to identify those outliers. Okay, and now this time they are called as an extreme outlier, not only the outlier. This time they will go, we will call it as an extreme outlier. Okay guys, anyone having a doubt regarding this thing, this concept interquartile range, or we can proceed? Guys, no? Oh, what did I explain again? So this is a interquartile range, guys. So by this is a formula for interquartile range, Q3 minus Q1. Okay, where is this applied? By you can apply it anywhere. You can apply this thing. You can try to like you can try this thing with any data set. Okay, my objective is what? My objective is to check whether my data set is containing outlier or not. Okay, so I can apply this knowledge anywhere, with any data set, because and we can identify whether my data set is having an outlier or not. Where does p equals to 30 came in the previous example? Oh bhai, p is equals to 30 because I asked you to find the 30th percentile of your data set. So that is why your p is equals to 30. Okay, so at the time of writing the formula, I told you that p is what? P is percentile of interest. Okay, Sumit Panchal, now it is clear. That was the part of question means. It is clear now. Okay. Fine. Okay, so even guys, you are having you can use. Okay, so we are not going into like detail of Python, like we are not getting into the detail of each and every library. And definitely even like we don't have like time, so we need to arrange a different like Python session for this to understand the whole of Python and even the whole of libraries associated with the Python. But as for a timing, we can but even I can give you like a kind of an idea or kind of a a small example to understand that with the formula, with like writing a code, you can even identify an outlier, okay, by using this IQR and by using an empirical rule, whatever like the things you want. And even you can try to identify by using some graph, okay, by using some charts. Okay, so I think we already imported an NumPy. So with the help of NumPy, we can do like a small calculation. And for the graph, okay, so for the graph or chart, we can use like two basic libraries which is available inside a Python, and that is called matplotlib.pyplot.splt. So one is matplotlib and another one is a Seaborn. Okay, now guys, just take like one dummy data set over here, or even I can take like a data set from the real scenario, but then I need to give you the data set also. So that is and even I need to then use a different library. So leave it, just try to take one like dummy data set over here. So 11, 14, 12, 15, 17, 13, 18, 21, 22, 27, 29, 30, 25, okay, and then 16, 17, okay, then 23, then I can take like maybe some outlier, okay, so 120, then a 31, then I can take maybe a 26, then maybe a 15, then I can take maybe 142, then I can take maybe 165, yeah, okay, and then I can take maybe 32, and finally I can take like 10. Okay, so maybe these are the total number of like values I can take along with 3 outliers. Okay, so there are like 3 outliers I take. I took like 3 outliers over here. Okay, and I think every one of you is definitely able to like observe those 3 outliers. Okay, so this is like my data set D. Fine. Now with the help of like a Python code, just try to identify the outlier. Okay, so with the help of an like Python code, try to identify an outlier. Okay, so the first thing which we can try to do is we can try to like identify, or we can try to detect with the help of empirical formula. So in case of empirical formula, I already told you that if the value is okay, so in case of an empirical formula, what happens? So if the value is lesser than mu minus 3 standard deviation, or if it is greater than mu plus 3 standard deviation, then in both the scenario the value can be considered as an outlier. Okay, so I can make like a very small function, and this function is like a very simple to understand. So this is how you can like create a function in a Python by using a def keyword. Okay, and then I can like pass my data over here. So data, fine. Now I can take one threshold value. So threshold value may be 3, because I'm going to take like up to 3 standard deviation. Then we can find out a mean. So how we can find out a mean? So mean can be find out with the help of np dot mean. I think you all know that with the help of np dot mean, I can find out a mean. So mean of a data. Okay, I will explain you like this code also, don't worry. And then standard deviation I can find out with the help of np dot std, and then I can pass the data over here. Fine, no issue. Now I can run a like for loop. So for I in data, so for I in data, what I can do, I can take a like Z score. So Z score, you all know, yesterday itself in a standard normal distribution, we calculate something called a Z score. Okay, so what is the formula for Z score? It is nothing but x minus mu upon sigma. Okay, if you remember, so yesterday itself we discussed the formula for a Z score, a standard normal distribution, where we are trying to standardize our data set. And what is the meaning of standardization? What we are able to achieve with the standardization? So after the standardization, the mean of my data will become 0, and the standard deviation of my data will become 1. So yeah, we can try to find out a same thing over here. So I minus mean, so I minus mu divided by standard deviation, STD. So this is fine. Now I can calculate over here that if np dot, and this is what I'm going to calculate, np dot abs. Abs means absolute value, because I don't want any negative value over here. So np dot abs of a Z score. Okay, so if np dot abs of Z score is greater than t, okay, so it should be greater than t, then okay, so if it is greater than t, then definitely that particular value, I can call that particular value as an outlier. Okay, so I think I need one more thing over here. So I need one append empty list over here. So this is my empty list. So now I can append my outlier inside this list. So outlier dot append. Okay, I think now this is clear. And now what I can do, I can try to like return an outlier. Okay, so guys, I think if you are doing like this Python for the very first time, so maybe you are finding a difficulty to understand this function. So guys, this is a way we can try to create a function in Python. Okay, so suppose I will give you an example first. So just try to like understand with the example first, and then you can easily relate this thing with this example. Okay, so suppose like function is actually used for if you create any like a function. So I think till now whatever the code we have done, okay, so in yesterday's session, whatever the code we have done, so we code those things in a scripting way. Okay, so just like we are writing a story. Okay, so we code in a way that we are writing like a story for something, someone, or like maybe some movie story or something. Okay, but so that is not that is a scripting way of programming. Okay, now there is two more ways of programming. One is a functional way of programming, another one is a object oriented way of programming. Okay, so like guys, functional way of programming means we are trying to make our code a modular one. Okay, so like last time when we try to add two numbers, so what we can try to do, so we can define two variables, and we can pass like two values over there, and then we can put like add operator in between, and then we can add two numbers. Okay, so that is what we can do in the previous case. Okay, so that is what we can try to perform in a previous case. But if I want to make my code a modular one, and if I want to so I can add two numbers, or at every time when I want to add two numbers, so I need to define a new variable, and then I need to assign new numbers, and then I can add two numbers. Okay, but if I create a function, if I create a one function of like addition operation, so what I can do, by calling that function again and again, I can add any of two numbers. Okay, and so I can call that function at any point of a time, and then I can pass any of two number, and then those two numbers will be added. Okay, so this is what you can say advantage of creating a function in a Python. Okay, and that is what we are trying to do over here. Okay, so just try to understand this like function, guys. So how we can create this kind of function? So we can use a def keyword. Now we can pass any so because if you want to perform a summation, so it will be between two numbers. Okay, and then here what I can do, I can try to okay, so def add, and then I can take okay, so even I can pass a number in below. So even I can try to perform C is equals to A plus B, and then I can try to write return C. Fine. Now this is yeah, we are done with the writing a code. Sorry, we are done with creating a function. Now we need to call the function. Okay, so by using the function name, we can call the function, and now I can pass any two numbers. So suppose 4 and 6. Okay, so yeah, you can see the output 10. Now I can use this sum SUMM at any point of a time. Suppose if I want to add two numbers, so if I want to add two numbers, and if I want to change these two numbers this time, so yeah, change it, no issue. Now it will be 50. Okay, so this is how we can make our code as a modular one. Okay, and that is why we are creating a function over here. So anytime if I want to detect an outlier, so what I need to do, I can directly call this function as detect outlier, and then I can pass my data set. So this time my data set is nothing but D. Okay, so this time my data set is nothing but a D. So sorry, detect outlier. So this time my data set is nothing but D. So I can pass D over here. Suppose if you create a data set with L, so you can pass L over here. Okay, so even I have L also. So if you if you want to pass L, so you can pass L, and if there is any outlier inside an L, so it will detect. Otherwise, it will it will just throw you out with the empty list. Okay, so guys, now just check whether I'm able to get any outlier or not. So yeah, it is able to detect an outlier, and with this formula it is able to detect 165 only as an outlier. Okay, now guys, you can also try to make this a calculation. Okay, so if I try to calculate the length of this D, so just try to check the length of this D. Okay, so if you want to do this calculation, so you can do it by yourself. So 24, so there are total 24 elements are there. Okay, now what calculation is going on? So just try to think. Okay, just try to understand that what calculation is going on. Okay, so we are trying to find out a mean. Okay, and then we are trying to find out the median. Okay, so just try to find out the mean and median separately. Okay, so the mean for this data set is what? So the mean for this data set is nothing but 35.125. Okay, and then try to calculate the standard deviation. So what is the standard deviation of this data set? So that is nothing but 41.64. Okay, so this is like interesting one. We got a mean as 35.125 and we got a standard deviation. Okay, so if I run this thing again, yeah, 41.645. Okay, now guys, this is a mean and standard deviation. I think up to this point everything is clear to you. Now we are trying to run a loop. So what is the meaning of this loop? So we are trying to iterate each value one by one. Okay, so for I in data means it tries to iterate each value one by one. Okay, so the first value of I is nothing but 11. Then the second value of I is nothing but 14, then 12, then 5, then 17, then 13, then 18. Okay, so this is how it tries to iterate. This is how it tries to iterate over the complete data set. Okay, so now it tries to check for I in data. Z score is what? So Z score is nothing but 11 minus mu. So what is a mu over here? So 11 minus 35.125 divided by 41.64. Okay, so just to get the Z score, guys, what will be the Z score? So just okay, even if you want to calculate, so you can try to like calculate separately. So my Z score, suppose if I try to like calculate this thing, so suppose just write a Z over here and just make this calculation over here. So I minus mean. So what is I? I may be the 11, first value is 11. Then mean is nothing but a 35.125 and then divide this value with this value. So everything is possible in Python. Okay, and that is why I prefer Jupyter Notebook, because in Jupyter Notebook you can see like each code line by line. Okay, you can split the code into like parts. So my value is minus 0.57. So after applying this absolute, we got a 0.57. Now just try to check whether this 0.57 is greater than like 3 or not. So this 0.57 is not greater than 3, so it is not considered to be an outlier. Okay, so guys, even this 3 is not, I think, a good value. I need to like maybe calculate. Okay, so this is where I make, maybe I'm making like some mistake in like calculating threshold. Okay, I think we are making some mistake, because this threshold should not be a 3, it should be okay, 1 second, guys. Yeah, I understand. So this should not be a 3, this should be this should be a mu. Okay, so mean, and then like a plus 3 standard deviation. And okay, so here I need to like create two things. Okay, so I need to create the upper bound and we need to create the lower bound, and then we need to like make this calculation. Okay, yeah, I'm making a mistake over here, that is why we are getting just one value over here. Okay, so even I need to like make this calculation over here, then I can take a threshold value. So even you can try to take in this way. So just try to write a t is equals to what? You can make this calculation over here also. So mean maybe a minus 3 standard deviation you can take. Okay, minus 3 standard deviation. So it may be the lower bound. So LB I can write. So mean minus 3 standard deviation. Okay, so here I need to write like a mean, and then STD. Now it is fine. So my LB is equals to minus 89 point this, and then I can take a upper bound. Okay, so just copy this thing and make it upper bound. So U, and then again U, and then this should be a plus. Now calculate it. So 160. Okay, so even guys, if I take like 3 over here also, then it is again, then also it is, I think it's somewhere it is checking. Maybe I'm not able to find out. So even we can take we can make two conditions. So even we can make like two condition over here. So even we can take elif condition also. Okay. Although even if we write this value also, then also we will get a like single outlier. Okay. With this calculation also we will get a single outlier as 165. Okay, because the upper bound is 160 according to the empirical formula. Okay, so according to the empirical formula, the upper bound value is 160. So we will get just a single outlier from this data set if you are using like this formula. Okay, over here. Now guys, okay, so even I think one more thing which you can try to identify, like one more through like there is one more formula through which you can try to identify just by using a graph. So what you can do, you can try to use a box plot. Okay, so SNS dot like box plot, and then you can pass the data set. Okay, and now check. Okay, so yeah, just see. So this box plot, what this box plot giving you guys? So this is the minimum value. Okay, so this last thing is a minimum value. Then this is okay, and my minimum value is 11. So yeah, it is correct. Then this is the 25th percentile. This is the 50th percentile, and this is the 75th percentile. And according to empirical formula, guys, try to understand. According to empirical formula, this should be your maximum value. Okay, this should be your maximum value. But we got like three outliers. Okay, so according to like this box plot, we got like three outlier over here. Yeah, we have like three outlier. If you talk according to a normal distribution, so definitely 120, 142, and 165 is kind of an outlier, and that is what we are getting over here. Okay, so even identifying outlier with the box plot is super easy, and it is it gives you much better result. Okay, it gives you much accurate result. Okay, because it gives you this kind of dots. Okay, so suppose if you are having one more outlier, so you will get one more dot over here. If you are having like two more outliers, you will get two five dots over here. Okay, so even you can try to increase it, and you can try to see that how many outliers we are having over here. Okay, so with the help of this box plot also, you can easily identify that whether in my data set I'm having an outlier or not. Okay, and the second way is IQR, but in case of an IQR, you need to follow some steps. So first you need to sort the data set, then you need to calculate Q1 and Q3, then you need to calculate IQR by using a formula Q3 minus Q1. Then you need to find out the lower fence, means lower bound, by using Q1 minus 1.5 into IQR, and then you need to find out the upper bound. So these 5 steps you need to follow, and then you are able to get whether in my data set I'm having an outlier or not. Okay, so just try to that way. Okay, I think here I need to make like two calculation, but I'm making just one. So that is why maybe we are not able to get a good result. So just try to do something over here. So a data set, then a sorted is also a function through which you can sort your values. So this is the first step. We need to sort my data set first. Okay, so I will get a sorted data set. So this is my sorted data set, fine. And then the second step, I need to find out a Q1 and Q3. So a Q1 and Q3. Okay, then how we can find? So Q1 is what, 25th percentile, and Q3 is what, 75th percentile. Okay, so I can pass the D over here, and then I need to find out two percentiles, 25th and 75th. Sorry. Okay, let me check with this. I think.
But we no need to sort it out, right, to find out the percentile using these methods.
What? I didn't get you again. Come again, please.
No, I think the formula itself will automatically determine, and I think internally it will sort it out, I believe. Correct?
Yeah, percentile, no?
Percentile, yeah.
Yeah, fine. So I think okay, fine. Thank you. Okay, with this also we are able to get. Okay, so I'm just telling you the procedure. Okay, so after sorting we get the percentiles, 25th percentile and 75th percentile. Okay, Q1 and Q3. Now, next thing we need to find out that IQR. Okay, so what is IQR? IQR is equals to Q3 minus Q1. So it gives you an IQR, fine, 14.5. Okay, now let me get the lower bound. What is lower bound? So lower bound is nothing but Q1 minus 1.5 into IQR. Okay, this is the lower bound. Now what is the upper bound? Upper bound is equals to, I think this will definitely help us to get an outlier. 1.5 into IQR. Okay, and I made a mistake over here. This should be plus. Okay, so we are able to get upper bound and lower bound, I think. Now, so yeah, I think what is my lower bound? Just calculate it. And what is the upper bound? So -7 and 51. Okay, so upper bound is -7 and lower bound, lower bound is -7 and upper bound is 51. So guys, any value, now any value beyond this thing is considered to be an extreme outlier. So just try to see guys in this whole data set. I think we got three values, which is bigger than a 51. Okay, 120, 142, 165. Okay. So these are considered to be an outlier. Okay, and even along with the box plot, we have one more plot which is called a Wallen plot. Okay, so even I can show you the picture of Wallen plot. Okay, Wallen plot. So even with the Wallen plot, and in case of an Wallen plot, we always try to see the interquartile range. Okay, so this is a Wallen plot, guys. So if we try to draw the Wallen plot, so we'll get like this kind of a structure. So in the middle, we have a median. Then we have an interquartile range, IQR, and this is 1.5 into IQR. Okay. Now any value beyond this 1.5 into IQR, that value considered to be an outlier. Okay. Fine. So this is how we can try to calculate an outlier in our data set. Fine, guys. So even with the help of plotting, we can check. So if I try to even with the help of this box plot, we can try to identify whether my data set is containing an outlier or not. And even with the help of this IQR also, we can try to identify whether my data set contains an outlier or not. Okay, I think I'm making some mistake. Maybe I'm definitely making some mistake over here, which I'm not able to identify. So, and that may be the possible reason will not maybe this value is this value is not something which we are expecting. So it and that is why we are not getting a correct identification over here. But I think with this and with this IQR and with this box plot, we are easily able to identify that yes, my data set containing 3 outlier, and with this IQR also we are able to identify that my data set containing 3 outlier, because my lower fence is -7 and my upper bound is 51. So any value beyond this -7 is considered to be extreme outlier, and any value above 51 considered to be an extreme outlier. Okay, so we are having 3 values which is more than 51. So these 3 values are considered to be an outlier. Okay, guys, got it? Anyone having any doubt regarding this IQR and this box plot? Guys? No? Let me draw SNS dot Wallen plot, and then what kind of a thing I can pass over here? Yeah, this is my volume plot. And let me, and even this structure shows you that yeah, you are having an outlier. Okay, because my maximum value is 50, you can see. Okay, so I'm expecting that from at till here we need to I need to close this thing, but we are having like some outlier, and that is why we are getting this kind of a curve. We are getting this kind of a plot over here. Okay, and even maybe I may have something. Let me check whether I'm having that particular inner is equals to box. I have some orientation or not. Let me check. I think yeah, I can use this orientation, and let me find out over here parameters. Orient is where is orient? Yeah, so I can use this orient maybe. This is not possible. Okay, fine. So yeah, with this volume plot also we are able to identify that yeah, we are having an outlier. Okay, so just try to compare this image with this image. Okay, so we need to close up to this point, but we are not able to close it. We are able to get again some value, and because we are having some values over here, so we are having a one value at 120, then we are having one value at 142, and then we are having one value at 165. So that is why we get this kind of a curve again. If you increase the number of outliers, so you will get a bigger you are able to get this particular graph will something more bigger. Okay, this mouth will be much bigger. Okay, fine guys. Plotting anything is not difficult. Okay, with a Seaborn, anything you can plot. Just try to write SNS and then plot name. And if you want to understand what are the parameters you need to pass, so if you are using a Jupyter notebook, just press on the shift tab. Okay, shift plus tab. Okay, and with the help of shift tab you are able to get all the parameters, and you are able to even what are those parameters what are all those parameters you are able to get. So all the definitions are also written over there, so it is not a very big thing to understand. Okay guys, anyone having any doubt or anything you want to ask regarding this IQR or maybe percentiles, quartile, outlier? Okay guys, so this is clear to everyone. Okay, so I think that yeah, no one is having any doubt, so we are good to go. And now I'm going to start a new thing, a new module, or you can say a new chapter. So I think yesterday also I give you an idea that from today we are going to talk about an hypothesis testing. Okay, so now I am going to start with the hypothesis testing. Okay, so guys, just give me a 3 minutes of break, and you guys also take a time 3 or 4 minutes to utilize whatever you have learned so far, and then we'll come back with the hypothesis testing. Okay. Okay, guys, come back. Okay, so any one of you like can tell me what okay, so if you have any idea, okay, so if any one of you is having like any idea, so can you like tell me about like a hypothesis testing, that what you guys understand with the hypothesis testing? Anyone? Okay, so I think guys, yesterday itself, and even on the like very first day, I give you kind of an idea of feedback about an hypothesis testing. That hypothesis testing is nothing but we are trying to, okay, so in a like in a bigger scenario, we are trying to test. I can say the credibility of our statement, the credibility of our claim. Okay, and now what kind of a claim? So what like what kind of a claim, guys? So a claim is nothing but we are making a claim that like whatever the conclusion or whatever the prediction, whatever the inference, whatever the decision we are making for a population based on the information on the sample data, that claim is correct. Okay, so now this is like a statement, this is a claim we are like making, this is a kind of a statement we are making, and now with the help of hypothesis testing, we need to like we need to understand the credibility of our statement, that how up to how much extent my statement is correct. Okay, so I need to check whether this statement is correct or not, so I need to prove myself mathematically. Okay, so now this time I need to prove myself mathematically. Okay, guys, so there, and now this time hypothesis testing, like we can use the concept or an idea of an hypothesis testing. So what is a hypothesis testing? So if you like guys, now I can give you like an example, a lot of example to understand this concept, and even you can also try to understand if I give you the like a definition. So if you want, you can try to write down that hypothesis is an statement, assumption, or claim about the value of the parameter. Okay, hypothesis is an assumption, statement, or claim about the value of the parameter. Okay, and and this is what like this is like what something which we are doing on a daily basis. Okay, so like suppose if someone making a claim, or someone like gives a statement that Dhoni is the best Indian captain ever. Okay, so suppose like I make this statement. So suppose I'm a big fan of Dhoni, so I make this statement that Dhoni is the best Indian captain ever. Now we need to check this statement, we need to like check my claim with the help of like some kind of a mathematical calculation. I need to check whether this statement is true or whether a statement is false. Okay, so we need to check this statement. So what I can do, I can take like all the records, okay, of the past captains, and then the captains after Dhoni. So I need to like check all the records. I need to like go through all the data, and then I can understand whether or whatever the statement I am making, whether this statement is true or whether this statement is false. Okay, so this is what we can try to do in case of a hypothesis testing. Now there are two kind of a hypothesis testing, guys, or you can say sorry, there is two kind of a hypothesis. Okay, so hypothesis is nothing but it's a statement, assumption, or claim. So one is called a null hypothesis. One is called a null hypothesis. It is denoted by H naught. Okay. And another one is called an alternate hypothesis. And it is denoted by H. Okay. Now, what do you mean by a null and alternate hypothesis? Okay. So, guys, whatever the statement or whatever the claim made by anyone. Okay. So, suppose I think all of you are like we all are like aware about like kind of an advertisement going on a television on a TV. Okay. So every day we are able to see like some kind of an advertisement like the advertisement regarding a soap company, and then the advertisement regarding like you can say like a Colgate, or maybe any kind of a toothpaste. Okay, and they are making a claim that that this particular soap company is able to okay, so with the help of so if you are using this soap, so you are so it is able to reduce, or this is able to clear 99% of the germs. Okay, so this is a kind of a claim they are making. Okay, so this particular like soap is able to clear 99% of the germs. Okay, so now this is a claim, this is a statement, so this is what we can call it as a null hypothesis. Okay, whatever the claim or statement passed by anyone or passed by any company, if we call it as an null hypothesis. Now just opposite of null hypothesis. Okay, so opposite of this statement is what? That this particular soap is not able to reduce or is not able to remove the germs, is not able to remove 99% of the germs. Okay, so this is called an alternate hypothesis. Okay, so just opposite. Okay, so just opposite of a null hypothesis is called an alternate hypothesis. Okay, guys. So and even this thing is very much you can relate like this concept with our like you can say a system. Okay, so with our like court processing system. Okay, so inside a court also, so according to Indian penal code, we can we always try to like say that uh, any like person, so even the concept of null is very similar to the innocent until proven guilty. Okay, so I think this is kind of an statement or this is a kind of like thing which is inside our Indian penal code, that a person is considered to be an innocent until he is proven guilty. Okay, so it means what? The null hypothesis for that particular person is innocent. Okay, and alternate is guilty. Okay, but we can only so we need to find out, so we need to find out that advocate is need to find out the sufficient evidence to make him to prove him guilty. Okay, so that particular advocate is need to find out he needs to like get a sufficient evidence to prove him guilty. Okay, so this is what we are trying to do in case of a null and alternate hypothesis. Okay, and even the soap example is like very much with the soap example, it is very much easy to understand. So all soap company claims that its product kill 99% of the germ. So this is what we can call it as a null hypothesis. Now we need to have a sufficient evidence to reject the null hypothesis, to reject his statement. Okay, and if you are able to reject the null hypothesis, then it means we are able to accept the alternate hypothesis. And alternate of this is what? That the soap company, that particular soap is not able to kill 99% of the germs. Okay, so I think this idea of hypothesis is clear to everyone. Yeah, this idea of null and alternate is clear to everyone. Guys, any difficulty, any problem, doubt regarding this null and alternate hypothesis? No? Okay. Now, guys, now we need to see some more kind of a concept. Okay, so there is one thing which is called okay, so there are two kind of a test. Okay, so inside a null and alternate itself, we can we have like two kind of a testing. So one is called we have a one tail test, we have a one tail test, and we have a two tail test. Okay, now to understand this thing, just take an example. Okay, so to understand this like concept of one tail and two tail, just take an example. So suppose if I ask you the question, so I think every one of you using a straw. Okay, so at a time when you are in a restaurant and you order like some kind of a beverage, so along with that like beverage, you order like you definitely got like a straw. Okay, Now definitely there is a company, there is a straw manufacturing company who is like producing a straw in a use number. Okay, so there is a straw making company who is manufacturing a straw in a use number. So guys, always we always need to care about that, like the straw diameter. Okay, so the diameter of a straw should not be a very high and it should not be a very low. Okay, so the diameter of the straw should not be a very high and it should not be a very small. Okay, so it should be like one accurate size. Okay, so suppose one a manufacturing company making this claim that their straw, okay, so whatever the straw they are producing, their straw is all on an average, whatever the number of straw they are like manufacturing, all the straw is having a diameter of maybe a 10 mm. Okay, so on an average, so this is like a claim made by like this manufacturing company, one of the manufacturing straw manufacturing company, that whatever the straw they are manufactured, the on an average their diameter is nothing but a 10 mm. Okay, on an average. Fine. Now, what is the alternate of this statement? What is the alternate of this statement? So, guys, we all know that if the size of the straw, okay, so suppose if the diameter is more than 10 mm, okay, so suppose this 10 mm is a standard diameter. Okay, now if you got more than 10 mm, or even if you got lesser than 10 mm, in both the way, like a customer may not satisfy. Okay, so customer may find a difficulty by for using that particular straw. Okay, so the alternate hypothesis is what? So alternate hypothesis is that the diameter is not equal to 10 mm. Okay, now in this case, in this scenario, if we try to build this kind of a graph. Okay, so if we try to build a like a normal distribution curve. Okay, so we need to test on both hand side. Okay, so now in this case, in this particular, for this particular example, we need to test for both hand side. Okay, so even so now testing means we need to check. Okay, so testing means we need to check whether we are able to reject the null hypothesis or not. Okay, so by with the help of testing, we are trying to understand that whether we are or whether we are going to reject the null hypothesis or not, we are going to reject accept the null hypothesis. So this is what we are trying to check with the help of like one tell or two tell test. Okay, so now if you want to reject the null hypothesis, so how you are able to reject? If the diameter if the like on an average, if this diameter is maybe a greater than 10, or even if it is lesser than 10, in both the condition we are going to reject the null hypothesis. Okay, so here we need to check on both hand side. We need to check on this side also, and we need to check on left hand side also, and we need to check on the right hand side also. Okay. So this is what we call a two-tail test. Okay, this is what, and here we have like some confidence, and this is what we call the margin of error. So I will talk about this thing in just maybe in 20 minutes, which is called a confidence interval. So guys, wait for that. But for now, just try to understand that we are not confident enough to accept the null hypothesis if my values lies in this region, or whether if my values lies in this region. In both the condition, we need to reject the null hypothesis. We need to reject this claim, and we need to accept the alternate hypothesis. So this is what we call a two-tail test. Okay, because we are trying to test on both hand side. We are trying to test on both hand side. Okay, we are trying to test on the right hand side also, and we are trying to test on the left hand side also. Fine. Now let's take another example. So this is an example of two-tail test. Okay, now let's take another example and try to understand one-tail test. Okay, so guys, suppose you are like maybe you are moving from one city to another city. Okay, so you are doing a job, or maybe you are a student, and maybe for your masters you go on to the different college, and so you need to like live in the different city. Okay, so you need to search for an apartment. Okay, so you need to like search for an apartment to live in. Fine. So now you are making definitely you need to like have one budget in your mind. Okay, so all of us is having like kind of a budget according to our condition. We have like one budget in our mind. Okay, so suppose you are like searching for a 1 BHK, or you are searching for maybe a 2 BHK, and you are making an statement. You are making a statement that I will buy an apartment. I will buy an apartment only if the price is lesser than or equals to 15,000. Okay, or maybe a 20,000. Okay, so I will buy an apartment. I will buy an apartment if the price is if the price is if the price is lesser than or equals to 15,000. Okay, now what is the alternate hypothesis for this? What is the alternate hypothesis of this statement? I will not buy an apartment. And which condition? Okay, now guys, I think we all know that in which condition we are not he's not able to buy an apartment if the price is greater than 15,000. Okay, so it means that we are able to reject the null hypothesis only in the condition if the price is greater than 15,000. It means if I draw this like curve. Okay, so if I draw like the same curve over here, so now this time we need to check on this side only, on this right hand side only. Okay, so now this time we need to check on the right hand side only. Okay, because if the price is even lesser than 15,000, then also I'm going to buy, and if it is 15,000, then also I'm going to buy. But if it is greater than 15,000, then I'm not able to buy that apartment. Okay, and I'm going to reject the null hypothesis. Okay, so this is an example of one tell test. This is an example of one tell test, right? Yeah. Okay, so yeah, if the rent if the yeah if the rent of an apartment is lesser than 15,000 or greater than 15, okay, so yeah, I think all of you are able to understand. Even you can try to plot this kind of an hypothesis. You could try to like think of this hypothesis with respect to some like examination result also. Okay, so I'm able to get this college if my number is if my marks or if my percentile is greater than 90. Okay, so in that condition also we need to check for the one hand side or maybe only the right hand side. Okay, or even I can check for the left hand side also if I change my statement. Okay, so guys, this is what like a one tell test. So here we need to perform one tell test, and guys just try to understand. So like right now we don't have a knowledge of this confidence interval and margin of error, but this is an area of a confidence. This is an area of a confidence. Okay, so this is an area of confidence where we are able to accept the null hypothesis. Okay, we are able to accept this like statement. Okay, and this is an area where we are going to reject the null hypothesis. This is an area. So if my value lies in this area or if my value lies in this area, so we are going to reject the null hypothesis. So that is why it is called a critical reason, this particular reason. And in this scenario, both the side, this reason and this reason is called the critical reason. So critical reason means what? So I think guys now all of you can define critical reason. So critical reason is nothing but a reason where we are able to reject the null hypothesis. Okay, so just if I try to relate this example with like this thing with the like that person is guilty or innocent example, so we are able to prove. Okay, so that particular advocate is having a sufficient evidence to prove that yeah, this person is guilty, he is not innocent. Okay, so if my value lies in this reason, so we are able to reject the null hypothesis. So that is why it is called a critical reason or rejection reason. Okay, guys, this is how you can make a different. You can differentiate between a one tell or two tell test. Okay, guys, clear to everyone? Okay. Okay, now come on to the one more important concept, guys. So there is one more thing which is called a type 1 or type 2 error. Okay, so type 1 and type 1 and type 2 error. Okay. Now what is the meaning of type 1 and type 2 error? Just try to understand. Okay, so I think you all are able to understand that H0 is nothing but a null hypothesis. Okay. Now there is like two conditions over here. Okay, guys. So now let's try to understand like this table. Okay, and let's try to understand what is type 1 and type 2 error. Okay, so suppose your null hypothesis, okay, means a claim. Okay, so suppose your null hypothesis is true. Okay, your null hypothesis means whatever the claim or is whatever the claim or whatever the like assumption is making by like maybe any person is true, but you reject. Okay, okay, so it is true. Okay, it is not false, but then also you reject the null hypothesis. Okay, so this is what we call a type 1 error. Okay, because we are making an error over here, we are making a mistake over here. Okay, so even it is true, we are rejecting the null hypothesis. So this is what we call a type 1 error. Fine. Now my my null hypothesis is false. Okay, so my null hypothesis is wrong, and we are rejecting the null hypothesis. So I think it's a correct decision. So this is a correct decision, guys. Now here my null hypothesis is true and we are accepting the null hypothesis. So again, I think this is again a correct decision. This is again a correct decision. And now here my null hypothesis is false, but I'm accepting the null hypothesis. Okay, so again this is an error and this is called a type 2 error. Okay, so this is called a type 2 error. Okay, now guys, just try to like understand this thing with an example. Okay, so according to like Indian Penal Code, okay, so a person is innocent until he is proven guilty. So suppose he's so the claim is he's innocent. Okay, he's not guilty, he's innocent, but we reject the null hypothesis. Okay, so even he's innocent, okay, but we reject the null hypothesis. It means we like a judge gave a wrong verdict, and because of that maybe he's sentenced to a life imprisonment or something. Okay, so this kind of an error is again like a very like disastrous one. Okay, so this is what like type 1 error. Okay, so even the person is innocent, but somehow that advocate is able to prove him a guilty. Okay, and even the judge is making a wrong verdict, so he rejects the null hypothesis and he accept his his guilty, and then he give him like some kind of a punishment that maybe a life imprisonment or something. Okay, so this is what a type 1 error. Okay, so yeah, this is a disastrous one. And even here that person is guilty. Okay, so that person is guilty, but he again that he's able to save himself. So although he is guilty, but like advocate is not having a sufficient evidence to prove his prove him as a guilty, and that is why a judge is like needs to accept the null hypothesis, and that is what a type 2 error. Okay, so it's again a disastrous one, and it is also a disastrous one. Okay, so this is what a type 1 and type 2 error. Fine. Okay, and now so I think, yeah, you can take like some more example, like example of soap company, example of soap, example of toothpaste, and you can try to relate this thing with the like null and like this true and false thing. Okay, and then there are like two things, like there are two values. One is alpha. So alpha is what? Alpha is nothing but it is a probability. This is a probability of rejecting. Alpha is what? Alpha is nothing but probability of rejecting null hypothesis when null hypothesis is true. Okay, so alpha is nothing but probability of rejecting null hypothesis when null hypothesis is true, and beta is what? Beta is a probability of accepting null hypothesis, accepting null hypothesis when null hypothesis is false. Okay, it means what? It means what, guys? So alpha is nothing but it's alpha is something where we are, and this alpha is nothing but it is also called a significance, like a level of significance. Okay, so this alpha is also called, you can also call it as a level of significance. So we are rejecting the null hypothesis. We are rejecting the null hypothesis when it is true. So it is what? It is like type 1 error. So you can even you can say in this way that alpha is nothing but it is a probability of making a type 1 error, and beta is nothing but it is a probability of making type 2 error. Okay, and here beta is also called as a power of test. Power of test. Fine. Okay, so yeah, guys, this thing is clear to everyone. Yeah, probability of making type 1 error and probability of making type 2 error. Fine. So this thing is clear to everyone. So critical reason, tell one tell and two tell test, and type 1 type 2 error, and null and alternate hypothesis. So these four things is clear to everyone. Yeah. Okay, guys. Thank you so much. Now. Okay. So guys, now by using all this concept, now we can use some formula. Okay, so we can use some formula like a jet test. So there are like different kind of a tests are available. Okay, so we can use a like jet test, we can use a like t test, we can use a chi-square test, we can use ANOVA test. Okay, so now by using like there are like so many different formulas are there, and by using those formulas we can try to we can calculate we can try to calculate whether the statement is true, means whether the null hypothesis is true, or whether the alternate hypothesis is true. Okay, and you are able to see that whatever we are going to like understand, or whatever we are going to like build, all those are like statements we are going to build with respect to a sample and population. Okay, this is this is a true, that this is what we are going to check, all the things we are going to check with respect to a sample and population. Okay, now guys, just okay, so if you want, you can try to write down the steps. Okay. Hello, guys. Okay. Now I'm audible to everyone. Hello. Can I get quick yes if I'm audible to everyone?
Sir, you are audible, sir.
Okay. Thank you. Okay. So yeah. So now guys, you need to like follow some steps to like suppose if you got like if you have any kind of a question in front of you. So I think tomorrow we are going to talk about maybe those questions, and even today I will give you like some one glimpse of like what kind of a question we are going to solve. But whenever we have like those kind of a question, like a question based on a hypothesis testing. Okay, so every time you need to like follow these 4 or 5 steps, and then you are able to do like any kind of a calculation, you are able to make any kind of a decision. So even after doing hypothesis testing, even after like using maybe a mathematical formula or doing like any kind of a calculation, my main job is to get a my main job is to get the result. My main job is to make a decision. Okay, so the very first thing is we need to like set up the null and alternate hypothesis. Okay, so the very first thing we need to identify, or even I will write that identify null and alternate hypothesis. Okay, so even guys I will okay, so if when you are trying to I already shared the notebook like book with you. So if you try the question by yourself, so you will definitely find some difficulty at starting. Okay, if you do like maybe 3 or 4 examples, then after you are able to do that. But at starting you are finding difficulty to identify null and alternate hypothesis. So this is the main step. So identify the null and alternate hypothesis. Okay, then the second is what you need to like decide the level of significance. Okay, so one like just write down, I will tell you that decide the level of significance. So even this level of significance is nothing but a margin of error, which I need to tell you. Like a level of tolerance, you can say. Okay, so that is alpha. Okay, so it is denoted by alpha. So it may be a 5%, it may be a like 2%, it may be a 1%. Okay, so we need to decide, or we need to check. Then the third thing, we need to select the type of sorry, yeah, we need to choose the type of test which we need to perform. Okay, so we need to like choose the type of test. Okay, so type of test means guys, as I told you that there are like different kinds of tests which are available. Okay, so we have like G test, T test. Okay, so as per the question, we need to choose the type of a test. Okay, so it may be like a G test, it may be a T test, it may be a chi-square test. Okay, so we need to like select. Okay, so there are like 3 more tests, but we are going to talk about only these 3: G test, T test, and chi-square. Then the fourth thing, we need to even maybe this thing is maybe the third step, that we need to check whether this is a one tell. Okay, so we need to identify, or we need to decide. We need to decide between one tell and two tell test. So we need to check whether it is a one tell or whether it is a two tell test. After this, we need to calculate. Okay, so based on whatever the test we have chosen, so we need to make this calculation. So we need to calculate our test statistic, we can say. So we need to calculate the test statistic. Okay, so whether it is G test, T test, or whatever is that. Now we need to obtain the critical value. Okay, so we need to obtain the critical value. So obtain the critical value, or you can say the critical or first you need to obtain the critical value from the table of these test statistics. Okay, So guys, every test statistics have their own like table. Okay, so I will show you even the book which I have shared with you. You can go on to the last and you are able to see like different tables for the G table. So you are able to see the G table, you are able to see the T table, you are able to see the chi-square table. Okay, so even if you go on to the Google and just write G table, so you are able to get like one G table. If you write T table, so you'll get like complete T table over there. And if you search for the chi-square table, so you'll get a complete chi-square table over there. Okay, so we need to obtain the critical value, and with the help of critical value itself, we are able to decide the critical reason. Okay, so we need to obtain the critical value from the table of this test statistic to decide the critical reason. Okay, and the last step, now we are ready to make the decision. Okay, so now we are going to check whether my test statistic value. Okay, so after this like calculation, after the calculation of from this step, we are able to get some value. Okay, so we need to check whether this value, whether this test statistic value lie in a critical reason or not. If it is lie in a critical reason, then we are going to reject the null hypothesis. And if it is lie beyond, if it is lie in a acceptance reason, so we are going to accept the null hypothesis. Okay, so this is the last step. Okay, so we are going to check whether the test statistic value lie in the critical reason. Okay, so if it is lie in the critical reason, so even you can write if the value lies in the critical reason, we are going to reject the null hypothesis. Otherwise accept it. Okay, so guys, these are these are the 7 steps which you need to follow to perform your hypothesis testing. Okay, these are the 7 key steps which we need to follow to understand the hypothesis testing. Okay, guys, if you want to write, you want me to turn the page, or is it clear to everyone? Guys, tell me, you want to write the steps. If someone not able to write, so I can turn the page. Okay, sure. So guys, these are 7 steps which you need to follow. I will read it again. So first, we need to identify null and alternate hypothesis. So based on the question, so we have a question in front of us, and based on that question, we need to decide what is a null hypothesis. So which statement belongs to a null hypothesis and which statement belongs to an alternate hypothesis. Okay, even if we are able to identify the null hypothesis, so alternate hypothesis is just opposite of that. Then the second thing, we need to decide the level of significance. So this is what I will tell you, that what is the meaning of level of significance. Just wait. The third step, we need to choose the type of test. Okay, so even based on the question only, we are able to decide that whether we need to perform the G test, or whether we need to perform the T test, or whether we need to perform the chi-square test. Okay, so based on the question only, we are able to decide. Then the fourth is we need to decide whether it is a one-tailed test or whether it is a two-tailed test. Okay, even from the null and alternate hypothesis, if you are able to write null and alternate hypothesis mathematically, so we are able to understand that it is whether it is a one-tailed or whether it is a two-tailed. Because if it is null hypothesis, we got a equals to sign, and in alternate hypothesis, if we got a not equals to sign, it means it is a two-tailed test. And if in null hypothesis we got a lesser than or equals to, or maybe a greater than equals to, it means it is a one-tailed test. Okay, now the fifth test, we need to calculate the test statistic. So every test statistic is having a different formula. So G test is having a different formula, T test is having a different formula, and even a chi-square is having a different formula. Okay, So based on that formula, we need to we need to make our calculation. We need to calculate like a G test, we need to calculate a T test, and we need to calculate the chi-square test. Then the sixth step is what? We need to obtain the critical value from the table of this test statistic. Okay, so there is a like different table available for each kind of a test statistic. Okay, so for a G test we have a different table, for T test we have a different table, and for chi-square test we have a different table. Okay, so for each test statistic we have a different tables. Okay, so from that table we need to obtain the with the help of that table we need to obtain the critical value, and based on that critical value we are able to decide the critical reason for that particular question. Okay, now we need to compare this critical value with this like test statistic value, and we need to check whether this test statistic value is lie within the critical reason or not. Okay, if it is lies in a critical reason, then we are going to reject the null hypothesis. If not, then we are going to accept it. Okay, so we so these are the like 7 steps which we need to follow to perform our hypothesis testing. Okay, now it is clear to everyone, guys. Okay, now so another thing which we need to understand is a confidence interval. Okay, and along with the confidence interval we need to understand the margin of error. Okay, and even this margin of error is also called as a level of significance, alpha. Okay, so but before going into this, so we are able to understand these two concepts only with the help of estimator. Okay, only if we understand the estimators. Okay, so guys, this understanding this estimator is pretty easy. So I think in our everyday life, okay, so this is something related to our like daily routine. Okay, or I think yeah, if I'm running maybe some kind of like a market, or maybe I'm having some kind of a shops, so there we are making a like estimation, we are making some kind of estimation every day, even in for our life also. Okay, so even for our future, or maybe for our like a day, so maybe like even I make like some kind of an estimation for tomorrow, then maybe a day after tomorrow. Okay, so we all are like making this kind of an estimation for our like day-to-day life. Fine. Now there are something called a point estimation and an interval estimation. Okay, so suppose guys, if I give you this, if I give you some assignment, okay, suppose I give you some assignment and I ask you that how much time you are able to complete this assignment, or in how much time you are able to deliver this work to me. Okay, so maybe some of you is able to like give me the answer that on the 6th day, okay, on the 6th day, I'm able to submit this assignment to you. I'm able to deliver this work to you. Okay, so some of you may give this answer that on the 6th day, I'm able to submit this assignment. Fine. So this is what we call the point estimator. Okay, this is what we call the point estimator. And then some of you is able to give me the answer that we are able to submit this assignment, or we are able to deliver this work in between 6 to 8 days. Okay, so here you are talking in like in term of an interval. Okay, so that is what we call the interval estimator. Okay, so estimator means what? An estimator is nothing but it's a rule, or you can say even it's a formula that tells us that how to calculate an estimate based on the information in the sample. Okay, so based on like some information, so even you are making this estimation, how you are making this estimation, okay, how you make like this estimation, so you're making this estimation based on like some like sample information. Okay, so you are working on like a project from a very long time, and you have like a lot of projects around you. Okay, so you're working maybe on multiple projects, you are working on like multiple things at the same time. So you are trying to like keep time, you are trying to like give some amount of time for all of that, and then you are able to tell me the answer that in between these two this I'm able to deliver the assignment, I'm able to deliver the project. Okay, so this is what we call the estimator. Okay, so estimator is a rule or a formula that tells us how to calculate an estimate based on the information in the sample, and then we can. So, and then there are like two different kind of an estimator. One is a point estimator and another one is a point estimation and a interval estimation. Okay, so when we are trying to like make some kind of an estimation, like a kind of a fixed estimation. Okay, so whenever we are able to give we are able to predict any fixed value. Okay, so whenever we are able to predict any fixed value, so it is a point estimation, and whenever we are able to estimate something or we are able to predict something in form of an interval, so it is called an interval estimation. Okay, fine guys. Now I think okay, so if we don't know about the statistics, okay, so I think even if we don't know about statistics, okay, so I think in the real world many of us don't know about the statistics. So there are a lot of people around us who don't know about statistics. So even those people can also make this kind of an estimation. Okay, so everyone for their life or for their future definitely making like some kind of an estimation. So this is not something that this is not like something which is followed by a statistician only. Okay, then also if I'm making an estimation, okay, so suppose if I'm making an estimation as a statistician, so my estimation should be more perfect, it should be a more accurate than a normal human being. Okay, so then a normal person, my estimation should be a more accurate. Okay, so that is why we are trying to define this a confidence interval. Okay, so we are always trying to define like a kind of a confidence interval. So confidence interval or the confidence in means what, how much confidence we are. Okay, so how much like confidence we are, so for making any kind of an estimation. So suppose as a statistician or maybe as a data analyst, someone asks you, so suppose someone running like a electronic shop or maybe someone running maybe a supermarket, and he asks you that maybe regarding some electronic item. Okay, so maybe regarding some maybe an electronic item, maybe a PC or maybe a laptop, maybe a mobile phone. So suppose he asks you that how much mobile phone did I order, should I order this time or maybe for the upcoming month, so that I will be in profit. Okay, so suppose like a new mobile comes into the market, and as a data analyst, he trying to ask you that he give you the data of his past profits and loss and all. Okay, so past sale you can say, and then he wants to ask you that just to give me like one estimation that in what range I should order the mobile phone so that I will be in profit, I should not get any kind of a loss. Okay, now as a statistician you need to like make some calculation, and then you need to tell him one particular value. Okay, so you can tell him, okay, so you should order your like mobile phone in this range. Okay, now you should be and you need to be like pretty sure. Okay, and that is why we need to construct a confidence interval. Okay, so there are like some standard confidence interval, guys. Okay, so although it may possible that you are maybe a 50% confidence, but 50% confidence is not like applicable anywhere. So there are some standard confidence like 90% confidence, you should be maybe a 95% confidence, you may be a 98% confidence, and a last one is 99% confidence. Okay, so you can make a statement that okay, you can order a mobile phone in this range and I will be 90% confidence. Okay, so confidence means what, how much percentage. Okay, so confidence interval means what, how much percentage or how much confidence you are, whatever the assumption you are making or whatever the estimation. Okay, so not assumption, this time assumption is different thing. So whatever the estimation I am making, I am 90% confidence about it. Okay, or whatever the claim I'm making, I'm 90% confidence about it. Okay, so if I'm 90% confidence, so yeah, this is my 90% confidence. And if it is a two-tailed test, it means 5%. Okay, so now if I'm 90% confident, it means what? It means there is a 10% chance of making an error. Okay, so if I'm 90% confidence, so this is my area of confidence. Okay guys, so this is what I am telling you. So this is what I like acceptance reason every time. Okay, so this is what I am showing you at that point of time. So this is my area of acceptance, or this is my confidence reason. Okay, so this is my confidence area, guys. Okay, so this is my confidence area always. Fine. And this is my you can say in terms of an hypothesis section, you can say this is a critical reason, or even you can say this is like area of tolerance. Okay, so if I am 90% confident, so suppose if I'm not 90% confident, it means what, that there is a 10% chance of, maybe there is a 10% chance that you might suffer a loss also. Okay, so if I am 90%, so anyone in this entire world can't be 100% accurate. Okay, so if I am 90% confidence, it means that there is a 10% chance that I can make an error. Okay, so even whenever we are trying to we are trying to prove the null and alternate hypothesis, so we always take some some percentage of tolerance. Okay, so I can tolerate an error up to what value. So if I'm 90% confidence, it means my tolerance percent is 10 error. Okay, so my margin of error is 10%. Okay, so if it is 10%, so it means 5% on both hand side. Okay, if it is two tail test, if it is one tail, then 10% on a single side, whether it is right hand or whether it is left hand. Now the second confidence interval is a 95%. So if I'm 90%, 95% sure. Okay, so second is 95%. So if I'm 95% sure, it means 2.5% both hand side. So 2.5% over here and 2.5% over here. Now, at 98% confidence, it means margin of error is what? So, and even this 10% is called a level of significance. This 5% is called a level of significance. Now, if it is 90, if I am 90% confident, it means margin of error is 2%. Okay, so margin of error is like 2%. Okay, it means both the side we are having a 1% chance of making an error. And if I'm 90%, 99% confidence, it means a 0.5% on both hand sides. So here also I'm having 0.5, and here also I'm having a 0.5. Okay. So guys, this is my confidence area. This is my area of confidence, and this is my margin of error, or a tolerance area, or you can say a level of significance. Okay. So in this case, level of significance is 2%, and in last case, a level of significance is 1%. Okay. And even if we have a formula to calculate the confidence interval, so even we have a formula to calculate the confidence interval. So even if you want to calculate this thing, so this is nothing but a point estimation. Okay, so a point estimate plus minus margin of error. So even this is a formula to calculate the confidence interval for any question. So even if you're not having if the confidence interval is not given, and if someone asks you to calculate the confidence interval, so this is how you can even calculate the confidence interval. Okay. Fine guys, so yeah, this is how we can calculate the confidence interval. Okay, and I think now this second step is also clear to everyone. I think from here now the second, first, third, fourth, each and every step is clear to everyone. The only thing which we are not seeing so far is the table of my test values. Okay, so even you can go on to the Google right now also. So tomorrow also we should go on to the Google, and I will give you the Z table, T table, and I will show you that how you can understand, or how you can read the value of how you can get the value from there. Okay, so the tables are available on the internet, and we can see the value from like a table, and then we can able to construct the critical reason, and then we can try to check whether my test statistic value lies in a critical region or whether it is away from the critical region. Okay, so guys, I think yeah, this is it for today, and from tomorrow I'm going to I'm going to take like questions on a hypothesis testing. So we are going to solve questions on a hypothesis testing tomorrow, and then after solving some questions on a hypothesis testing, then on the last day we are going to perform, we are going to even I will step by step. Okay, so I'm going to talk about 4 things tomorrow. Okay, so G test, then T test, then chi-square, and then Pearson correlation. Okay, so there is one more kind of a test which is called Pearson correlation. So I will talk about a Pearson correlation also, and then on the last day I will and I know you know that every time I also talk about like significance. Okay, so along with the formula, along with the definition, I will talk about the significance, that what is the role of this thing in a machine learning. And then on the last day I will show you with the help of Python, maybe I will show you that yeah, this is how you can utilize this thing inside a machine learning also. Okay, although guys, I must insist you that I got like this idea that we can, even we are conducting like a program on every maybe 2 weeks or 3 weeks in a gap of 1 week. So even if you guys like interested, so we can go for we can extend this thing, and then after this a machine learning basics, and then a Python, then machine learning, and then advanced machine learning, then a deep learning. So we can go in this way also. Okay, even we are planning to like conduct this kind of a session. So now it's yeah, it's up to you if you want to join. And tomorrow, okay, so after tomorrow's session I will share the document of hypothesis testing. Okay, so even if you want to do some more practice, or if you like whatever the things I have written over here. Okay, so I have written like lot of steps and all the things over here. So I will create one document for all these things, and I will give you that document also. Okay, so but day after tomorrow, not today. Okay, sorry, it's tomorrow, after tomorrow's session. Okay, once I need to create this. Okay guys, so yeah, thank you so much. Now if you have any doubt, so yeah, you can ask. Oh, 3 things in a chat. Sure, sir, you told that you will share the book of, yeah, I shared the book of probability and statistics, guys. So I think Ruby ma'am shared a drive link with you. So inside that drive link you will get 3 things. Okay, so one is a NumPy, like a detail of NumPy in a PDF. Then a notebook for a Python basics, means a Python data structure and data type. If you want, even I will share the notebook of for loop and the functions. Okay, so I have a separate notebook for all this. So even if you want, I will share like these 2 notebooks, okay, of Python also. And this book is already there. Okay, the book which you are talking about, this book is already in that drive link. Go and search. Okay, and from when AI deep learning. Okay, for this okay, you can like contact to like Ruby ma'am. She will tell you maybe in the first week of March we are going to start. So you can make a contact. Okay, I'm not sure about the date, but most probably from the first week or the second week we will start. Okay, so yeah guys, thank you so much. Okay.
Thank you, Shivam. Thank you so much. As you specified earlier, we are yet to plan the programs actually, and we will be planning soon. And I'll share you all in WhatsApp group. So please be in touch with us. And thank you so much. Thank you all the participants. And this is for today. Thank you so much. Kindly join tomorrow at 6 p.m. Thank you. Kindly end the session, ma.
Okay.